Did I give you any work to?
Yes, you did.
Oh, okay. And you were able to do them, right?
Yes, sir.
Okay. Let me bring this down a bit. I think I have to change. I'm coming. Okay. Now the next topic I want us to move on. Did we complete the change of subject?
Yes, we did.
Okay. Okay. So are you okay with said?
Yes, please.
Okay. So if you are okay with said, I think we can move on then. So after said, we can do number basis and modulo arithmetic.
Sir.
Are you okay with that one too?
Yes, please.
Okay. So once you are okay with
Mr. Dixon.
Okay, Kobe.
Yeah, please. Online class, we started factor theorem. I wanted to know if you could help me with that one.
We started what?
Factor theorem.
Factor theorem.
Yes, please.
Okay. Okay, then I think that would help. That would help. But the ones that you do that you find it very difficult, then I explain to you. So polynomials, right?
Yeah, that one and the remainder theorem.
Yes, factor theorem and remainder theorem. Okay. Let's do it. Let's do it. So polynomials. So let me let me get the note, and then I'll mirror it for you. Very, 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 very easy.
Okay, sir.
So let's tackle remainder theorem first.
Okay, sir.
Let's tackle remainder theorem first. So let me mirror for you. Remainder theorem. Okay, so I think I can use this. Good. Very nice book. Let me save it. Okay. So let me mirror it for you. Screen share. Fire, please. Okay. So let me screen share. Okay. Share. Good. Good. So I think we're good. Okay. So let's get to work. Now the remainder theorem and the factor theorem. The remainder theorem and the factor theorem. Okay, so 1 minute coming. Okay, so I have it here. Share. Good. Okay. So we start from the left side, solving and simplifying polynomials. Now, before we move on to the remainder theorem, we should know how to solve and simplify polynomials. Now, polynomials are anything with a degree of 2. Now, a degree of 2 means that the x or any other variable that is represented in the quadratic is a square. It's a square. Now, you can have a cube, you can have raised to the power 4, you can also have raised to the power 5. So that is how it is. So in our study of quadratics, one of the methods used to simplify and solve was factorization. factorization. So for example, we may solve for x in the following equation as follows. So I have x squared plus 5x plus 6 is equal to 0. Is equal to 0. Now this is given to you as an equation, not an expression. So if it was given like x squared plus 5x plus 6 without any equal to 0, that would have been an expression. So this is an equation, quadratic equation, not a quadratic expression. No. Good. So they are entirely different. They are entirely different. Good. So that is how it is. So here we have two numbers. When you multiply, you have 6. When you add, you have 5. So that is 3 and 2. They are all positive. Positive 3 and 2. Good. So by factorization, you can do it this way. This is very simple by factorization. So once you have these factors, the reason why we call it factorization is that after you are done finding two numbers, when you multiply, you have 6. When you add, you have 5. Now you eventually end up having factors. Now the factors are x plus 3 is equal to 0 and x plus 2 is equal to 0. Those are the factors. Those are the factors. So that is going to be needed in the factor theorem. But then before we get there, this is the basics. Good. So here we can actually find the values of x. So hence x is equal to -3 or -2 are solutions or roots of the quadratic equation. Now, once we talk about quadratic and cubic equations, the solutions are the same as the roots. We call the solutions root. Yes. The solutions are the same as the roots. The solutions are the same as the roots. Good. A more general name for a quadratic is a polynomial. Mostly we give quadratic to only a degree of 2. Any number raised to the power 2 is a quadratic. And then any number raised to the power 3 is a cubic. It's a cubic. Good. And then we have numbers that are raised to the power 4, numbers that are raised to the power 5. So when you put them together, the general name that we give to these quadratic, these cubic, and number raised to the power 4 and 5, it's called a polynomial. Polynomial. Poly means more. So polynomial. Good. So that is the general name given to polynomial. So since the highest power of the unknown is 2, now the unknown function is the variable or the alphabet inside the equation that has been given to you. Good. So the method of factorization worked for quadratics whose solutions are integers or rational numbers. So you realize that in quadratics, we were able to factorize because we find two numbers. You multiply, you have this, you add, you have that. Good. But then you are moving a step ahead. Now, in the step you are moving ahead, the challenge is that you don't have a degree of 2 as the highest degree again. No. Here you have a degree above 2. A degree above 2. Now, in this case, that is where the factor theorem comes in. Good. I remember our first meeting, we went through this. I don't know, I quite remember, but then I think it is important for us to learn the basics. Let me get some water. It's important for us to learn the basics. Good. So for a polynomial of order 3, now the order is the power. So we have order, exponent, power, and it is also called a degree. A degree. So for a polynomial of order 3, such as x cubed plus 4x squared plus x minus 6 is equal to 0. Now we always consider the highest power in the equation. Even this can be rearranged. You can have 4x squared plus x cubed minus 6. But because the x cubed has the highest power, you always have to rearrange them for the x cubed to come first. So in some of the examples, they can just make them like that. So you need to have the capacity to know that, no, this is the highest degree, so I need to bring it first. It is all part of the understanding. It's all part of the understanding. That is how it is. So that is all part of it. Good. Now we continue. So the method of factorization may also be applied. I mean, at some point anyway, because you realize that the quadratic that we use the factorization to solve is inside this expression. Because aside the x cubed, you have 4x squared plus x minus 6, which is a quadratic. Good. So you can apply it anyway. So, however, obtaining the factors is not as simple as it was for quadratics. Now you've moved a step ahead. So you don't expect things to be very simple. But then it is not very, very difficult to. It is once you get the understanding, it is very, very easy for you to find the factors. It's not anything difficult. So obtaining the factors is not as simple as it was for the quadratic. So we would likely have to write down 3 linear factors, which may prove difficult. So in this section, we will learn to use the remainder and the factor theorems to factorize and to solve polynomials that are of degree higher than 2. Because when the degree is 2, we are using factorization. So when the degree is 2, we are using factorization. So obviously, the reason why we are employing remainder theorem and factor theorem is for degrees or orders that are above 2. That are above 2. So before doing so, let us review the meaning of basic terms in division. Basic terms. So this is long division from grade 1. From grade 1. So the terms in division. So we are familiar with division in arithmetic. Good. So once we have this long division, now we know that the number we are dividing, the bigger number anyway, it can be a smaller number or a bigger number. But in this case, the bigger number we are dividing is called the dividend. And the number that is dividing the bigger one is the divisor. Good. Now, after division, the answer you get is your quotient. It's your quotient. And then once you are through with the long division, the last number you have here is your remainder. Your remainder. So the number that is to be divided is called the dividend. The dividend is divided by the divisor, and the result is the quotient. Now the leftover is the remainder. The leftover is the remainder. Very, very simple. So if we have 489, now 489 is going to be 15 times 32 plus 9. Plus 9. Good. So we have the 489 is the dividend, the 15 is the quotient, 32 is the divisor, and the 9 is the remainder. The 9 is the remainder. Good. So that's from arithmetic. We know that we can express a dividend as. Now, dividend is equal to quotient times divisor plus remainder. This is a very important formula in polynomials. It is not anything difficult. It should be very, very easy for us to remember. Dividend. The dividend is equal to quotient times divisor plus the remainder, normally denoted by capital R. Capital R. Capital R. So dividend is equal to quotient times divisor plus remainder. Now with our basic mathematics, yes, you can get a lot of formulas from this. Now when we divide through by divisor, very, very easy at mathematics, divide here by divisor. So it means you're going to divide the remainder also by the divisor. And then you divide the dividend by the divisor. Now, you know, divisor will cancel divisor. So I am having dividend over divisor is equal to quotient plus remainder, quotient plus remainder over divisor. Now, in some books, they don't give this easy one. Like in some books, they don't give dividend is equal to quotient times divisor plus remainder. In some books, this is what they give. In some books, this is what they give. Dividend over divisor is equal to quotient plus remainder over divisor, which is very, very easy. Which is very, very easy. So when there is no remainder, your R is equal to 0 because there is no remainder. Now it means that the divisor is completely going into the dividend. For example, when I pick 25, now 25 divided by 5. 5 is completely going into 25, 5, without any remainder. So the remainder, the R is 0. R is 0. But when I pick a number like 26 divided by 5, now the 5 is going into the 26 5 times, remainder 1. Because 5 is 25, remainder 1, which makes it 26. Good. So when your remainder is 0, the follow becomes very, very easy. Now dividend is equal to quotient times the factor or the divisor. Very, very easy because now remainder is 0. So the process we followed in arithmetic, the process we have been following since grade 1, grade 2, grade 3, the long division. Good. The long division process is the same thing we are going to use to solve these polynomials. So long division, the number of times the number of times the divisor is going inside the dividend, you write it at the top. Now you come and multiply again, quotient times divisor. You write the number, you subtract. Very, very simple, like the long division. So the same process. So the process we followed in arithmetic when dividing is very similar to what is to be done in algebra. So examine the following division problems in algebra and note the similarity. So division of a polynomial by a linear expression. Now in polynomials, when we say something is linear, all linear expressions do not have any power, or they have a power more than 1. Now when x is standing alone, it means that x is raising to the power 1, but we don't write it. We don't write x raised to the power 1. We just write x. So all linear functions, their power is 1, which we don't write. Good. Now once the power is more than 1, it ceases to be a linear. So this is the hierarchy. We have linear, we have quadratic, we have cubic, and then it follows like that. Very, 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 very easy. So we can apply the same principles in arithmetic to dividing algebraic expressions. So let the quadratic function f of x represent the expression, represents the dividend, and then x minus 1 represent the divisor. So here, all that we are doing is we have a quadratic function. It is a quadratic because it is raised to the power 2. So any function, so this is how we represent function. Now f of x is equal to 3x squared minus x plus 2. Plus 2, this is your function. So this is how you write f of x. Or f of x can be f of x, which is accepted. F colon x. It is accepted. Or a function like this, f x. F x. They are all the same. They are all the same. Good. Good. So now we are dividing this linear, we are dividing the quadratic by the linear. So this is how the procedure goes. This is how the procedure goes. So let's see. So I have 3x squared minus x plus 2 divided by x minus 1. X minus 1. Now this is the same as, the same. Now this is the same as 3x squared minus x plus 2 divided by x minus 1. The same. It's the same representation. The same representation. Good. The same representation. Or I can write it in a long division form. If I have, let's say, 5 divided by 2. Now this is 5 divided by 2. 5 divided by 2. I can write the same thing as 5 over 2. I can write the same thing as 5 inside, 2 outside, long division. So, I mean, we are employing this from grade 1 or maybe grade 2. Very, 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 very simple. So now let's see, this is the divisor. That is the dividend. So I have 3x squared minus x plus 2 inside the long division sign. Now outside, I have x minus 1. Very, very simple. This is the same representation. So we have 10 minutes left, don't worry. I will forward another link and then you join. Good. This is it. So now with this, it is quite different from our normal long division because obviously our normal long division didn't involve variables or alphabet. They were just numbers. But then in this topic, we have alphabet or variables, which is the x. The x. Now the first thing you have to take note is that you are always dividing by the alphabet or the variable. That's the first thing you have to know. So you don't, once you see this variable and you see 1, don't get confused. It is the variable. So you check how many times is this x going into 3x squared. That is the only thing. The number of times this x is going into 3x squared. So x is going to 3x squared, 3x. Because 3x times x is 3x squared. 3x squared. Good. Now the next step is to pick this x and then check the number of times it goes into this x. So x will go into itself how many times? 1. So I have my sign minus 1. Now negative 1 times x is the same as negative x. The same as negative x. Very, 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 very easy. The same as negative x. Very, very easy. Good. So now good. So from here, No. Okay. So from here, our next step is to multiply. To multiply through by the 3x. To multiply through by the 3x. Good. So here we are going to have, so x is going to this 3x. Now we are going to use this to multiply through, and then we continue. So I have 3x times x. I have 3x squared. And then the next one is to multiply 3x and negative 1. So I have 3x times negative 1 is negative 3x. Now I am subtracting this. Good. So we hold on with this one. Now I am subtracting this. So I have negative 3 and plus 3. They will all go away. They will go away because 3x squared minus 3x squared is 0. Now negative is outside times negative. So this negative times this negative gives us positive. So positive 3 minus positive 3x minus x gives us positive 2x. Positive 2x. And now don't forget that we already have our 2 here. So we bring it down. We bring it down. Good. We bring it down. Now our next step is to check the number of times this same x. So it has always been the x. Always be the variable. So x will go into this 2x how many times? 2 times. 2 times. Good. Now once you have this, now we multiply 3 by the 2. So I have 2 times x, given as 2x, and 2 times negative 1, given as negative 2. 2. Good. Just as in long division, we subtract the whole thing. We subtract. Good. So I have negative 2x plus 2, or 2x minus 2x, which is 0. So here, they all go away. Now negative is outside, negative is inside. So negative 1 times negative 2, what do I have? Positive 2. Positive 2 plus 2, I am going to have 4. I am going to have 4. Good. I am going to have 4. So just as we know the parts, now the one we are dividing is the dividend. Dividend. Now the one we have here is the quotient. That is, this one is the divisor. And the one left is the remainder. The leftover is the remainder. Good. So we've been able to divide this guy successfully. Successfully using the long division method. So this is it. Using the long division method. So that is it. That is it. So from the above example, now we can deduce that 3x squared minus x plus 2 is equal to 3x plus 2 in a bracket, and then x minus 1 in a bracket, plus the remainder. Plus the remainder. Plus the remainder. Good. Now, when we consider the factor, the divisor is always the factor. Divisor is the same as factor. So divisor is the same as the factor. So when you hear the factor theorem, we are just talking about the divisor. We are going to work with the divisor. We are going to work with the divisor. Good. So here, if we equate the divisor to 0, we are going to have f of x is equal to 3x plus 2 times 0 plus 4. So if the divisor is equal to 0, it means that the whole expression, 3x plus 2, will be multiplied by 0. It will be 0. But we know that when this factor or the divisor, x minus 1, is equal to 0, now we can tell that x is equal to 1. X is equal to 1. Yes. X is equal to 1. Now, when x is equal to 1, it means that the function f of x should give us the divisor. Should give us the divisor. So now this is the basics for remainder theorem. This is the basics for remainder theorem. If we want to determine the remainder without going through the long division, we want to determine the remainder without going through the long division, we are just going to pick the divisor or the factor. When we pick the divisor, we equate it to 0. Now, when we equate it to 0, we are going to have a value for x. Now, what the remainder theorem is telling us is that when we put that value we found for x inside the function, we are going to have a number. We are going to have a number. The number we get is our remainder. Very, 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 very simple remainder theorem. Now let me get another example here, and then we find the remainder. And let's see. Let me